Hi, so I'd like to play a couple of rounds for bell work. By the way, this is assignment 9. We're talking about right triangle trig. Um, yes, yes, right triangle trig. But there's a bunch more, of course. Bell work today. Let's play a couple of rounds of what's my quadrant. Okay, so we know um, Descartes, Cartesian plane, named after him, French natural philosopher. Um, it's called this quadrant 1, 2, 3, and 4. Okay, and so I'm going to give you some information, and you're going to tell me which quadrant we're in. Okay, so what if sine of theta is less than 0, but cosine of theta is greater than 0? What quadrant must we be in if sine is less than 0 and cosine is greater than 0? What do you think? Give it a thought, and we'll have a countdown momentarily. Okay, so what do you think? What quadrants is sine less than 0? Well, sine are the y values, and the y values on the unit circle are negative in quadrants 3 and 4. Okay. What about cosine? When is cosine greater than 0? Well, cosine is the x values, and the x values are positive over here. Notice how we have overlap in quadrant 3. So what's my quadrant? I'm sorry, quadrant 4. That's my quadrant. Where both of these conditions exist, where we have that overlap, that's going to be our quadrant. Okay. So how about this one? What if tangent is less than 0 and sine is greater than 0? Where must we be if theta has these two qualities? Theta, the angle, lives in which quadrant if tangent is negative and sine is positive? Well, remember that tangent is sine over cosine. And in order for this to be less than 0, that means one of these is positive and one of them is negative. And where does that happen? Well, here I notice that the x and y are both positive. So positive divided by positive is positive. No, we're looking for tangent to be negative. Ooh, here, the x's are negative, but the y's are positive. What about quadrant 2? That's a good choice. So quadrant 2, and where else is tangent negative? Well, over here in third quadrant, both the x's and the y's are negative. So negative divided by negative is going to be positive. No, not quadrant 3. But over here in quadrant 4, the x's are positive, the y's are negative, and so there's another choice for us. So tangent less than 0 in these quadrants. Now, where is sine greater than 0? Well, we know sine, being the y values, is greater than 0 in quadrants 1 and 2. And lo and behold, where do I overlap? I overlap in quadrant 2. So quadrant 2 is my answer for this one. Okay? All right. So, yeah, what's my quadrant? Very, very common question. So please make sure you're comfortable with that. Let's move on to, because I actually have a bunch of things I want to talk to you about today. Let's move on to this. Will you please, and we're going to start this process by looking at with degrees, and then we'll segue into doing this with radians and see what we can see. Okay, so the sine of 30 degrees and the sine of 150 degrees. What do you notice about the sine of 30 and the sine of 150? What can you tell me about those? That's right. They are reflections across the y-axis. That's a good observation. Here's 30 degrees, and here's 150 degrees. But what about the sine value? remember, sine on the unit circle is the y value. Well, at 30 degrees, or at pi over 6, my y value is 1/2. And I also have that same amount of upness, that 1/2 amount of upness for 150 degrees. Isn't that interesting? Those are the same. How about the sine of 45 degrees and the sine of 135 degrees? What do you notice with those? This is root 2 over 2, and this is root 2 over 2. How about the sine of 120 and the sine of 60? What can we say about those? Well, the y value at 120 is root 3 over 2, and the y value at 60 degrees is root 3 over 2. Now, what do you notice about all of these? That's interesting. So these add up to 180, these add up to 180, these add up to 180. And so what I might say here is the sines of supplements, i.e. supplementary angles, the sines of supplements are samesies. Sines of supplements are samesies. Cool. And so now let's take a look. Does that change if we have this conversation in radians? How about the sine of pi over 6 and the sine of 5 pi over 6? Well, no, because the sine of pi over 6 is 1/2, and the sine of 5 pi over 6 is 1/2. And are these supplements? Remember, an angle and its supplement should add up to be pi. Do they? 1 pi over 6 plus 5 pi over 6 is 6 pi over 6, or pi. So, yeah, these are supplements as well. And so, again, the sines of supplements are samesies. Okay. So, what about the cosine of supplements? Can we say anything about the cosine of supplements? Let's take a look. Cosine pi over 4, cosine 3 pi over 4. These are supplementary angles because when I add them together, I get pi. Okay, what do you know about the cosine of pi over 4? Well, the cosine of pi over 4 is root 2 over 2, because that's the x value at for that angle. But what about cosine of 3 pi over 4? Well, that's over here in second quadrant, and the x values are all negative there. So this is negative root 2 over 2. They're definitely not the same. Okay, well, what about cosine 2 pi over 3 and cosine pi over 3? What can you tell me about those? Okay, so cosine here, 2 pi over 3 is this one, and our x value is negative, so we've got negative 1/2. But the cosine of pi over 3, well, pi over 3 is here. And I see that the x values would be positive and not, oh yeah, cosine 1/2. So what do you notice about the cosines of supplements? Cosines of supplements are, right, because these are supplementary, these are supplementary. What do you notice about these? These are opposites. Okay? And some people can hold these rules in their head, and that sometimes makes our problems easier when we're doing those evaluate cosine 3 pi over 4 kind of thing. Old school, they used to tell us, yeah, no, I'm not going to go into what they used to tell us in old school. Instead, I'm going to say, fabulous. So now we have these two rules for the sines and cosines of supplements. Excellent. We talked a little about even and odd in the last video. So let's see about that. So let's have an angle t such that the cosine of t is negative 3 over 4. Okay. So, um, yeah, the cosine is that. And actually, since this day is sort of talking about not just being on the unit circle, but drawing triangles, let's say that cosine is adjacent over hypotenuse. And so there's our t. And the same qualities for this angle hold true for this one. I'm going to call that one t prime. And I'm not going to talk about t prime much in these videos. I can say that t prime is the reference angle for t. But if this was 100 years ago, we'd spend a lot more time on this. At this point, I think no. I just want to use the Pythagorean theorem to find the missing side. 16 minus 9 is 7. So I have the square root of 7 here. Okay, so I've drawn my triangle. Magic secret of trigonometry. Draw a triangle and label it. We've labeled it with negative 3 over 4 for the cosine. And then we're asked some questions like, hey, what's cosine of negative t? What's the secant of negative t? And what's the sine of negative t? Well, negative t is, if this is positive t, then negative t is doing this kind of thing. So what can we say about the cosine of negative t? Well, the cosine of negative t is in fact negative 3 over 4. Now, how do I know that? Well, I can know that in one of two ways. One way I can know that is that this minus 3 is the same adjacent side for this angle as it is for this angle. And this hypotenuse is going to be the same in both triangles. This will be a negative root 7 because we're in third quadrant. Okay. So, yeah, cosine of negative t is negative 3/4. Now remember, we could also understand this because cosine is an even function. And even functions reflect across the y-axis. Yeah, I'm not seeing that here, so don't worry about that until we do the graphing. But because even functions do reflect in that way, notice whether I put in a t or a negative t, I have the same value for each of those. So here's positive t, and I see the cosine is negative 3 over 4, and here's negative t coming from the other direction, and in fact, that is also negative 3 over positive 4. Secant of negative t is just the reciprocal of cosine of negative t, so that's negative 4/3. And the sine of negative t, well, sine of negative t is negative root 7 over 4. And how did I know that? Well, I did have to find that missing side. I also needed to notice that that was below the x-axis, and therefore, or t-axis, and therefore needed to be a negative root 7 instead of this positive root 7 up here. Okay? Okay. I guess, yeah, no, I'm not going to go anymore with that. Do remember, though, at the end of the last video, we were talking about this case as well. Cosine of t equals negative 3 over 4. And then what about cosine of t plus pi? What did we say about that? Well, so here's our t with its negative 3 4-ness. And then what happens if t is an angle? What happens if we add pi to that angle? Well, remember, the whole circle is 2 pi radians. And so adding pi means going halfway around the circle. And so this angle here, this angle, is t That's this part. And here's adding half a circle, that's plus pi, brings us over here. Now, what's the relationship between over here and where t took us? Well, they're definitely on that line. And what can we say then? Well, this is going to be positive 3, this is going to be negative root 7, and this is positive 4. And so when I'm asked about the cosine of t plus pi, I notice here that if I add pi to that angle, now my cosine, instead of being negative 3/4, my cosine is positive 3/4. I wonder if that works for all cosines. Like, okay, here, this is what I mean. Let's imagine that our t value was here. There's our t value. And we'll call this negative 12 and negative 5, and that'll be 13. By the way, that's a Pythagorean triple, and you'll see those a lot in this trig semester. 3, 4, 5 is a triple. 5, 12, 13 is a triple. 8, 15, 17 is a triple, and 7, 24, 25 is a triple. And not only are these Pythagorean triples, but also multiples of these. So if I multiply all of those by 3, I'm going to have 9, 12, 15 is also a triple. And why do I point this out? Well, because if people give me these two, then I know I'm looking at a Pythagorean triple, and this one must be 5. But because I'm going down from the axis, it's a negative 5. Okay? All right, so here's t. Now, what about if we consider the cosine of t? Cosine of t in this problem is negative 12 over 13. That's the cosine of t. Now, if I go and add pi, that means I'm adding, going halfway around the circle, right? Half a circle here. What can we say about the cosine here? Well, this is 12, and this is 5, and this is 13. And cosine here, the cosine of t plus pi over 4, well, that's going to be positive 12 over 13. And so I know when I go halfway around with cosine, my answers are opposites. Huh. Okay. And what about this one? What about same situation? We're over here, and we have negative 3 and 4 and root 7. And there's our t. And now we're saying, okay, what about the cosine of pi minus t? Okay, so what is pi minus t? What does it look like? Well, pi minus t, here's pi, and if I take t away, I'm left with this angle. Now, that angle is less than pi over 2. This is an acute angle here, this t prime. So I could even draw it over here because it's acute. But if I were to draw it over here, because it's acute, and acute angles are only in quadrant 1, this has to be a 3, 4, and root 7. And so the cosine of this turns out to be 3 over 4, adjacent over hypotenuse. Now I know in this picture it kind of looks like we should have negative 3 over 4, but really because this angle is less than 90 degrees, we have to draw it over here in first quadrant, and in first quadrant cosine is always positive. All right? So, but wait, pi minus t equals s. Remember how we said 2 videos ago, I think, maybe just the last video, if I take an angle plus its supplement, they add up to pi. Great, so let's subtract that angle from pi, and what are we left with? Pi minus t is our definition of supplement. And in fact, we started this video talking about the cosines and sines of supplements. Remember when we talked about the cosine of pi over 4 and the cosine of 3 pi over 4? Well, this one was positive root 2 over 2 because it was in first quadrant, but this one, second quadrant, cosines are negative root 2 over 2. And while we said that the sines of supplements are samesies, we've got that the cosines of supplements are opposites. And this is just saying what's the cosine of the supplement. So I want to make an argument here. And my argument is those of you who just look at this and your brain turns off and fills with white noise, that's the situation where it's going to be really hard to understand what's going on here. But if you can stretch your brain enough to say, what do these symbols mean? Oh, they mean the supplement. Pi minus t finds me the supplement to t, because I know that a supplement plus an angle should equal pi. This is merely a way of saying, what's the cosine of the supplement of this angle t we were talking about? And we said earlier in class that the cosines of supplements were opposites and the sines of supplements were the same. Okay? So, So why don't we say that the sine of t is negative 3 over 4? And let's try these questions. Sine of negative t, cosecant of negative t, cosine of negative t, sine of t plus pi, and sine of pi minus t. Okay, let's see if we can do these. Of course, magic secret of trigonometry, draw a triangle. So sine is negative, and I've got negative 3 over 4, and here's my root 7 again. So this is our t, but I'm going to be using t prime to have this discussion. Okay, so negative t. Well, negative t means instead of going in the counterclockwise direction, I'm going to go clockwise. So I'm going to find myself here. That's negative t. Now, this triangle that I draw is very similar to the triangle I draw for t. Here, though, while this is still a positive root 7, this is now positive 3, and this is still 4. So when I ask about the sine of negative t, positive 3 over 4. Sine of t, sine of negative t, these are opposites. How come? Well, we know that sine is an odd function. And one of the things we mentioned briefly in pre-cal was that negative f of negative x. If we change both the x and y value, the signs on the x's and y's, and we get back to the original function, we say that function is an odd function. Sometimes this is written this way, where they move the negative here, and we say that's f of negative x. So what we're saying here is if we plug in that negative number into the function, we get the same value as the original function, but change the sign. Okay, so we plugged in a t, we got out a negative 3/4. So when we plug in a negative t, we're going to get out the opposite of what we got from plugging in the positive t. Originally, we got negative 3/4, so I'm going to multiply that by this negative, and now I have a positive 3/4. This is sort of an algebraic way I can understand these questions, but I can also understand these questions visually. Cosecant is just the reciprocal of sine, so I'm going to go with that. Now, cosine of negative t. Well, I've got this new triangle here, and the cosine didn't change. The sine flipped and became positive instead of negative, so my cosine is going to be root 7 over 4. Now, what about sine of t plus pi? Well, sine of t plus pi, let's go back to our original sine drawing. Here's our sine drawing. Negative 3, 4, and root 7. And so here's our t. And now we're saying, hey, what if I add pi to that t? Okay, well, from this point, I'm going to go halfway around, and now I'm over here. What can we say about the sine of t plus pi? Well, this is now positive 3, This is negative root 7, and there's a 4. And the sign here, ooh, positive 3/4. Oh, nice. And here, look, pi minus t. Hey, that's asking about the supplement. What's the supplement? I know sine of t is 3/4. What did we discover at the beginning of this video about the signs of supplements? We said the signs of supplements are samesies. I'm using that word not just because it's fun to say, but also because it's a word you're likely to remember. Signs of supplements are samesies, which means if this is my original angle, and that's the sine of that original angle, the sign of the supplement to that would have to be the same. Now, I have a problem here with the way I've drawn this and the definition of supplementary angles. Because remember, supplementary angles have to be positive, and they have to be between 0 and pi. Well, this t looks bigger than 0 to pi, yeah, because 0 to pi would stop here. So what I want to say is, yes, supplementary angles have to add up to 180. And yeah, this is true. Signs of supplements are samesies, but I'm being a little fast and loose with that. Because in this situation, no, I did not have really supplementary angles. However, this rule works even in this situation. So I'm going to go with it. Okay. Please ask Mr. Paz any questions about this, or reach out to me on GroupMe, and I'll try and clarify for you. Okay. The next time you see him, if he hasn't given you a unit circle quiz, I'm going to have encouraged him to give you a unit circle quiz. So please make sure that you can fill out the unit circle in 5 minutes. 1 minute for degrees, 1 minute for radians, 1 minute for x values, 1 minute for y values, which means you have 2 minutes to do all the coordinates on the unit circle, those ordered pairs, and then 1 minute to check everything. Okay? Now, I will say, when you first do this, there's a lot of thinking, and a lot of thinking, and a lot of thinking, and sometimes, 5 minutes goes pretty fast. But it would be really good, and it happens every year, that students are able to do this in 3 minutes instead of 5. Okay? So push yourself. You were able to learn the multiplication tables. I'm sure you can learn the unit circle as well. And the unit circle is coming up an awful lot for us. Okay, so let's take a look at these problems. What can you say about the sine of pi over 3 and the cosine of pi over 6? I know, I wasn't expecting that either, but go ahead, tell me. Sine of pi over 3. Okay, so I know where pi over 3 is. It's this angle here. And I know that the ordered pair here is 1/2 root 3 over 2, which means that this is root 3 over 2, and this is 1/2. And I know the sine of pi over the sine has got to be on the unit circle, the y value. Oh, well, that's root 3 over 2. Great. Now, what about the cosine of pi over 6? So cosine is the x value. What's the x value of pi over 6? Huh. Well, that's interesting. So what can you tell me about this case? The sine of 30 degrees and the cosine of 60 degrees. Okay, sine of 30, what's the y value for 30 degrees? 1/2. What's the cosine of 60? Cosine is the x value. 60 is, 60 is that one we were just looking at here. Here's 60. And this would be the cosine on the unit circle, and that's also 1/2. Oh, I think there's something going on here. Okay, and what about this situation? Here we go. Sine of pi over 4, yeah, is root 2 over 2, and cosine of pi over 4 is root 2 over 2. So, generate a rule for me. What does this mean? What's the relationship between these angles? Angle plus angle. What kind of angles are like that? That's right, these are complements. Complementary angles add up to 90 or add up to pi over 2. And what do we notice about the sine and cosine of complements? Well, it looks like the sines and cosines of complements are the same. But wait, it gets even better. What about tangent pi over 4 and cotangent pi over 4? Well, this is 1, and that is also 1. What about secant of pi over 3 and cosecant of pi over 3? Well, I don't know the secant of pi over 3, but I know the cosine of pi over 3 is 1/2, and secant is the reciprocal of that. So 2 over 1. What about this cosecant? Oh, I meant pi over 6 here. Sorry. Cosecant of pi over 6. Well, I don't know cosecant, but I do know that cosecant is the reciprocal of sine. The sine of pi over 6 is 1/2. So if I make the reciprocal, I get 2. So this rule about these things being the same, that's not just true for sine and cosine. It turns out it's true for all these pairs of functions as well. And so what do we call these? We call them cofunctions. Sine and cosine, secant and cosecant, tangent and cotangent. And we can say that cofunctions of, what was the relationship between these angles? They were complements. Cofunctions of complements are samesies. That's an interesting pattern to notice, and a reason why we're looking at secant and cosecant, as opposed to secant and cosine being reciprocals of each other. Many students want these to be the reciprocals. They do have a relationship. They are cofunctions. And one of the things we now know about cofunctions is that if we're doing cofunctions of complementary angles, like pi over 3 and pi over 6, those values will be the same. Okay, next. How about, oh, this is nice. So this is section 4.3 in our textbook, if you're looking for more information. And its primary goal is to talk to us about things that are not on the unit circle, but in fact have to do with triangles. And so I've got 24 and 10. And I'm asked here in the directions to find the 6 given 6 trig function values for theta. Okay, so here's the theta. Now, here I've got 10, 24, and if I'm going to find all 6, I'm going to need to know this hypotenuse. And it's pretty clear that I'm not on the unit circle anymore, because remember, on the unit circle, when I draw that triangle, the hypotenuse is always 1. Well, these things are way bigger than 1, so I can't be on the unit circle anymore. But that's okay, because most of our trig moves off the unit circle just fine. Remember, though, when we're talking about not on the unit circle, I can't say that cosine is the x value. Cosine is not 10 here. Cosine of theta is going to be adjacent over hypotenuse. So see, I got to find that hypotenuse. And those of you who have learned your Pythagorean triples which I mentioned a few minutes ago, and you learned about in geometry, well, then you'll be able to say that this is 26 without having to pick up a calculator. People will think that you are powerful math magic, when really all you were doing was saying 2 times 5, 2 times 12, so 2 times, right? What's our triple? 5, 12, 13. So I want 2 times 13. That's how I knew how to do that. Okay, so what are all the 6 trig functions for this? Okay, so the sine of theta is opposite over hypotenuse, 24 over 26, and you're welcome to reduce that. And cosine of theta, well, cosine is adjacent over hypotenuse, so 10 over 26, which is 5 over 13. And we'll want tangent of theta, and tangent is opposite over adjacent, 24 over 10, or 12 over 5. And of course, we need cosecant, because they asked for all 6. Sometimes they only ask for these 3, but often they ask for all 6. And so cosecant is just going to be sine flipped, 13 over 12. Secant is going to be flipped, so 13 over 5. And cotangent is going to be flip 5 over 12. So that's what they're asking us to do here. So what did we do? We took the triangle they gave us with 24 and 10. We either recognized that this was a Pythagorean triple situation, or we could use the Pythagorean theorem to find the missing side. And then we went through, with respect to this angle, naming all 6 trig function values. So how about you try this one? Okay, this is -7, this is 25, this is theta. So here's my triangle. First of all, is this on the unit circle? No. Look at the hypotenuse. If we were on the unit circle, this would have to be 1. This is not 1, so we're not on the unit circle. So I can't just say that the sine of theta is -7. Nope, can't do that, because that only works on the unit circle. Remember, sine is opposite over hypotenuse. Oh, opposite over hypotenuse, -7 over 25. So what about cosine? Well, in order to find cosine, I need this adjacent side. How can I find that? Well, if you're comfortable with your triples, you know there's a 7, 24, 25 triple. And if you're not comfortable with your triples, then you're going to have to go the long way and say x squared plus -7 squared should equal 25 squared. Or x squared plus 49 equals 625. And so x squared equals, is it 576? 24 and 25, yeah. And so x equals the square root of 576, or x equals 24. Yeah, I can get there. It's just going to take a whole lot more time. Yeah. Okay, so I need to find that missing side. Either I use my triples in this case, and trust me, I mean, it's not always the case with your textbook, but your textbook authors, they loved Pythagorean triples. And really, Pythagorean triples, your work takes so much less time if you know them and don't have to derive them every time. So it might be worth learning. Okay, so cosine adjacent over hypotenuse. And tangent. Tangent is going to be opposite over adjacent. And now what about the other 3? Well, cosecant is the reciprocal of sine, -25 over 7. And secant is the reciprocal of cosine, 25 over 24. And cotangent is going to be the reciprocal of tangent, 24 over 7, and don't drop that negative. All right. So, yeah, I would definitely be prepared to. This is the kind of thing that gets asked a lot on things like the ACT, and certainly on your upcoming assessment, I would definitely expect to see something like that. Okay, so draw a triangle. So how about draw a triangle And I tell you this. I tell you that the secant of theta is 17 over 15. And I tell you that theta is in, oh, better yet, let's play what's my quadrant. And sine theta is less than 0. Can that be true? Yes, that can be true. Okay, so what quadrant should I draw this triangle in? Secant is 17 over 15. So I guess cosine would have to be 15 over 17. But cosine could also be negative 15 over negative 17? No, because the hypotenuse is always positive, so I don't have to worry about that. So in what quadrants is cosine positive? Well, we know that cosine is positive in these quadrants. But I'm also looking to draw this triangle not only where cosine is positive, but where sine is negative. And sine is negative down here in quadrants 3 and 4. My overlap is in 4. So I'm going to draw this triangle whose secant is 17 over 15. 17, 15, like this. Hey, and guess what? This is a triple. 8, 15, 17, up. Negative 8, because sine is less than 0. Okay, so can you name the other, I guess we have 1, 2 trig values here. Can you name the others? So sine of theta is opposite over adjacent, no, opposite over hypotenuse, negative 8 over 17. Tangent of theta, that's opposite over adjacent, negative 8 over 15. And then, of course, the others. We've got secant theta was given. I don't have to worry about that. Cosecant theta. Well, that's the reciprocal of sine of theta. And cotangent theta is the reciprocal of tangent theta, negative 15 over 8. Okay? So I think what helps in these types of problems is, 1, draw a triangle. But maybe that's actually step 2. And step 1 is, what quadrant does this triangle live in? So you draw the triangle in the correct quadrant. I've noticed that people who don't draw the triangle in the appropriate quadrant, yet they often have this issue. They draw always in first, and they have 15, 17, and positive 8. Now, that means our cosecant, our tangent, our cotangent, and our sine are all going to be wrong. And that'll suck. So instead of having those all be wrong, what I would love it if you did is to play what's my quadrant first, and then draw the triangle, draw and label the triangle in that appropriate quadrant. Okay, so we were given these two pieces of information, the hypotenuse and the adjacent side. We used either our knowledge of triples or the Pythagorean theorem to find the missing side, and then we were able to go and answer all of those questions. Okay, what's next? Some more on identities? No, we talked about those in the last video. Though I will say here, the quotient identities. Yeah, we really need these. Cotangent theta is cosine theta over sine theta. Yeah, I know that tangent is opposite over adjacent, but tangent is also sine over cosine. And I know cotangent is adjacent over opposite, but cotangent is also cosine over sine. Okay? Okay. Yeah, and definitely keep these straight. Okay, sine is 1 over cosecant, not 1 over secant. It's really strange because people want to do this. And I think they want to do this because these are both beginning with S. Just like they want to do this. Cosine of theta equals 1 over cosecant theta. They both begin with c. Yeah, no, it doesn't work that way. Sorry. Cosecant is the reciprocal of sine, and sine is the reciprocal of cosecant. I'm sorry, 1 over sine is what cosecant is, and sine is 1 over cosecant. Okay, so please keep those straight in your head as well. All right, so last thing, how about a couple of these? Hey, what's the sine of 13 pi over 6? Yeah, and this is going to be one of those situations where I'm going to use my coterminal angles. I mean, you could count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6. Oh my goodness, it took me so long to count those and get there. I mean, I can do that, but I would much prefer to say, hey, what happens if I subtract 2 pi? Remember, we said we would find coterminal angles by either adding or subtracting 2 pi. And for me, what I want to do is I want to take this thing that's bigger than 2 pi and turn it into something that is on my unit circle, so something that is between 0 and 2 pi. So this is 12 pi over 6, and what am I left with is 1 pi over 6. Oh yeah, that's the little wedge for 1 pi over 6. And so I know that the sine of 13 pi over 6 is exactly the same as the sine of pi over 6. So what's the y value at pi over 6? I get 1/2. Okay? All right, so let's see if we can get a little more practice with this so that we can be comfortable doing this quickly. So sine of 5 pi over 2. What do you get for the sine of 5 pi over 2? 5, 4, 3, 2, 1. Yeah, so if I do 5 pi over 2 minus 2 pi, that's going to be 5 pi over 2 minus 4 pi over 2 is pi over 2. That's this angle here, pi over 2. So what's the sine of pi over 2? Because that's going to be the same as the sine of 5 pi over 2. And we know the sine is the y value there. So 1. Okay, how about the cosine of 9 pi over 4? What's the cosine of 9 pi over 4? 5, 4, 3, 2, 1. No, 9 pi over 4 minus 2 pi is pi over 4. And I know the cosine of pi over 4 is root 2 over 2. The x value at pi over 4 is root 2 over 2. Okay, I mean, I could count them. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Gosh, 9 pi over 4 looks just like pi over 4. Okay, so 2 ways to do those problems. How about the cosine of 17 pi over 6? What do we get for that? Cosine of 17 pi over 6. Well, 17 pi over 6 minus 2 pi is 17 pi over 6 minus 12 pi over 6. And so that's the same as 5 pi over 6. What's the cosine of 5 pi over 6? Well, what's the x value over there? And that is negative root 3 over 2. Okay, how about the sine of 21 pi over 4? Yeah, I really don't want to count this one. 21? No, but I will subtract 2 pi. 21 pi over 4 minus 8 pi over 4. That's going to give me 13 pi over 4. And guess what? That's still not on the unit circle. So I'm just going to subtract another 2 pi. Add or subtract 2 pi until you get something that you recognize on the unit circle. And so this is going to be 5 pi over 4. And so what is the sine of 5 pi over 4? Well, that's going to be in third quadrant. And so I know that's going to be negative root 2 over 2. Sine is the y value. And the y value for this angle, 5 pi over 4, And that's going to be negative root 2 over 2. Okay? How about this one? Tangent of 23 pi over 4. Oh, well, yeah, so 23 pi over 4 minus 2 pi, that's the same as 23 pi over 4 minus 8 pi over 4, and that gives me 15 pi over 4. Yeah, that's still not on the unit circle, so I'm going to do it again. 15 pi over 4 minus 8 pi over 4, and I get something I finally recognize from the unit circle, 7 pi over 4. 7 pi over 4 is here. The ordered pair, root 2 over 2, comma negative root 2 over 2. I want to know the tangent of that angle. And what is the tangent of that angle? Well, the tangent of that angle is y over x, or opposite over adjacent. And so that's going to be negative root 2 over 2 over root 2 over 2, which is negative 1. Okie dokie. Well, I hope that helps. I hope that you feel like you can do some of these. I definitely want to encourage you to get comfortable applying these unit circle values. That's hugely important, especially for people moving on to calculus. All right, well, ask Mr. Paz your questions or send me a message, and we'll take care of anything you need help with. Take care.